Good morning, everybody. Right, looks like the microphone is working today. Again, no more audio problems, please. All right then. Okay, so where did we get to? We had a weekend, didn't we? Yeah, that was it. That happened. That was nice. Hope everyone else had a nice weekend. I did. It was good. So on Friday we were talking about this stuff. Yeah. Which was the workflow planning. And the last stream I went over what it is that we were trying to do. The stream before that, we had a list of a list of steps, which we then turned into the little diagram, and then we started writing some code. And the idea of writing the code was that we then had a little tool which you could tell it to do something, and it would maintain some state, because this thing is stateful. It needs some state. So we were sort of going around this, going, okay, where can we write some code, right? And we got to assign variants to PCB units. This is the one that we got to over here. And I think also on Friday we were also looking at wanting to run stepwise tests in Rust, and I did a little bit of research over the weekend and on Friday afternoon regarding trying to find Rust crates that did this kind of thing. I found a couple, one of which was RSpec, this thing. And the way that it works is you go describe something, and then you have a context, and then you can do something before you run some tests and after you run some tests, and then you say, with the context, these things should happen. And, and this is all very well and good, and I tried it and I didn't like it. The reason I didn't really like it is because it sort of needs this sort of main method in it, but that's not really how you do tests in Rust. You use your IDE, you right click on a test item, and then you click run, and you can run just that specific one. And the way that this system sort of integrated with the existing test solutions and cargo tests and so on like that, I wasn't really happy with it, so I'm just like, nah. I also found RS test. I think I found this once before when I was looking for parameterized tests. And there was some stuff in here, but there wasn't anything to do with like a context for running stepwise tests that I could find. So I wrote my own. Let me show you what it looks like. Here we go. Where's my code? Yeah, here we go. This. Righto. Tests. So the idea is that you have some mod that describes a sequence, and it has a context, and the context has some things which are shared between all the tests for this sequence of tests. One of the things that is important for us is the state. So the idea is that we create a project or a job, and then we update this project as we go. And the project needs to live somewhere, so it has a temporary directory, it has a path which is consistent between it, there's a couple of arguments that are the same. So this is the context, and the idea is that all these things stay where they are until this context is dropped, or as it expires one way or the other. And the way that it works is you new up a new context, and we use a static mutex of an optional context and a sequence number and some lovely spin locky code so that the tests don't stomp on each other and they don't run in the wrong order. And this can also be improved over time, and we're not worrying too much about the implementation of that. It's only test code, it's not quite as critical as some of the production code. It needs to do its job so that we can focus on writing some more of the other tests, and then as time progresses we can come back to this sequence-based testing approach and maybe improve it somewhat. But you can still run one test at a time. from your IDE. But obviously, if you try and run the second test twice, you might not. It probably won't behave the same way the second time. So you sort of need to run all the tests in order, which isn't great if you've got lots of tests, because it means to get to the point where the test fails in a much later test, you have to run all the other tests first. And if you're doing debugging and all this kind of stuff and you've got breakpoints, it can be quite a faff. So stepwise tests are, but the alternatives aren't great either. So, we'll go with this way to start with, and then at some point we can decide whether it's okay, and then if it's not okay, we can say, okay, for the input of this test, you have this file and this state, and then you do the test. But I don't want to have to manage creating that state between the steps at this moment. So so the first step is to create the job by running the command with some arguments, right? And then it should say created a job, and a job file should contain a JSON job file should contain this stuff. Right, great, that all worked. Then the next thing we were trying to do was add the units to the unit assignments to the project. That works now too. So I finished that up on Sunday, I think. Yeah, Sunday. So now, when we say run the command with the name and say assign variant to unit, and you give it a design variant and the unit path, then it records that in a list. Yay! It's assigned. Brilliant. There are no tests currently to say what happens if you try and do the same thing twice, but I did put a to-do there for that. And maybe we'll use a hash map or something like this of unit assignments instead of this, and then adding it to the hash map would fail if the key was the same or something like that. I don't know. But at the moment there's just a vector of these things and a to-do, which is fine for now. So we did that, and I've got a commit with all this stuff in it, and I haven't pushed it yet, so let's do that. But before we do that, let's quickly run all the tests, which should be fine. This one. Let's see. Oh, what do we do? Oh, well, okay. We need to remove that. Oh, I'm so glad I did this now. What's this? Lib. Yeah. Okay. This is a dependency that I added and then later removed. This, don't need that anymore. That's when I was playing with RSpec to see if it was any good. Okay, let's amend that last commit. Oh, damn it. What did I just do there? Let me just squish those. Come on. That's it, there we go. Alright, now let's try that again. No. Yeah. There's a couple of warnings. So, because this sort of pattern of like wanting to run one test in isolation for the other one is common, I put that in a little mod by itself. But this is test code. So what we're going to do is say that it's allowed at the moment. Nothing currently uses this because I put it here and then refactored it and then made it part of the thing that has the context. So we're just going to allow it for now. And really helpfully, the tests aren't running on the command line. That's not good. Ah. But they worked that time. And now they're not working. Why? That's not good. Okay. Houston, we have a problem. Damn it. This is interesting because I know this sort of approach has worked previously with the mutex, the static mutex. So I'm not entirely sure as to why it's not running now. That's a bit weird. I just want to see if it does it with only one thread. No. You see, so it's when there's multiple test threads and they're interacting with each other that it fails. Let's say 2. Still seems okay. What about 3? Kind of weird. And it goes wrong. There's always something, isn't there? It's always something with this stuff. Alright, fine. Let's see if we can work out what is going on. But first, let's amend that commit. Okay. So it's probably getting stuck somewhere here. Now, I'm using the mutex for this, but honestly there might be a better way of doing this. Because spin locking is normally a bad idea. Because sort of what you want is some magic way to be notified when the other one is finished. And then everything just works. How is it not working? So it's doing acquire, and then it's saying loop forever, and try and lock the lock. And if you can't unwrap it, then you have to poison it. And this is because of some panic occurred in like one of the tests, for instance. And then you can't use the lock anymore. And then if you do lock it, you're basically supposed to, and the sequence is the right number, and the sequence is the first one, then you increase the sequence number, and nothing else should have the lock at this point, right? And then this mutex guard here, at the end of this loop. Ooh, wait, hold on, the sleep is at the wrong point. Let's drop the lock here before we sleep. That might be where it was going wrong. Yeah, we were sleeping. Okay, I think that fixed it. So we were holding the lock and then going to sleep, and then waking up and then dropping the lock, and then all the other threads do that. So maybe it would work eventually, but that seems to work for now. All right. If it stops working in the future, we'll come back to it and fix it. You know. Fine. Everything's fine. Okay. Okay. Now we can push this, and then we get on with the next thing. Happy days. And if anyone out there sees any problems with this, please let us know in the comments. Likely there's better ways of doing this. I think I was watching some good videos like maybe a year or so ago from John, what's his name? He was very good. John Geigen or something like this, like some Rust guy. Yeah, this guy. Oh, I nearly spelt his name right. This guy, yeah, this guy, he's pretty good. He has some great videos on Rust stuff. Very good way of explaining things. Very clear mind. Right, anyway, moving on. So we've got our thing where we create a job, and then we've got our thing where we assign a variant to a unit. Great. So I guess there's totes nothing else to do, right? Oh, I suppose we could have a quick look at the production code to refresh our memory there. So what happened in the production code? Yeah, a couple of things happened. The job name got moved to a common option that's shared by all of the commands. It's not an optional option. It's a required option. And then obviously the create command then doesn't have any other arguments. So you go name of tool dash name equals whatever, then you go create. And then for the second one, it's name of tool dash name and then assign variant to unit and then the parameters for that command. Right. And then there was a bit of common code to do with loading the project file, and that got extracted. Oh, sorry, saving the project file. That got extracted into a method. Here it is. It's well exciting. Yeah, and that then got reused by the new command that we added. And but before we could save a project, we needed to load the project in. So that got added. So we got a way of loading a project. Then we have adding the assignment. So on the project, we've got an implementation. We've got a little function here which just adds it to the end of a list, and that's the to-do that I mentioned earlier. So that's fine. Yeah, and then we save the project and say what we did. Easy. Okay, so back to this. So build each variant for each design. That happens using the other tool. Assigning variants to PCB units, fine. We're not currently validating this path, this key thing at the moment. I want to get more of the big picture in first, and then come back and fill in some of the little detail. You know, what knock off some of the to-do items. But let's concentrate on getting sort of like a vertical slice, as it were, and then come back and start, improving everything. So that's the process that I'm going for this development sort of cycle here. Yeah. And one of the reasons I'm doing it this way is because it helps you understand sort of where the pain points are in it and where you might need to focus more attention. I don't want to get too tied down in the nitty-gritty detail if I then find like this whole idea doesn't work, for instance, right? I would have spent loads of time filling around with keys and paths and all this kind of stuff only to find out there was something wrong with that idea, right? So this is the approach I'm going. Yes, so assign various PCB units, fine. Choose a process for each part. So we need a list of parts. And I guess we need the process as well, I I suppose. So how about when you create a project, it has like a default list of processes, which seems pretty fine, you know, pick and place being the default one, or manually place being the default one. Right? And then, I don't know, maybe in the planner software you can choose the defaults that you use when you create a new project, or when you create a new project it shows you what the defaults are and you can change them and add and remove to them. So fine. So choosing a process, we need a list of processes. That's going to be fairly trivial, and then we need to assign each part that we need from the variant to a process. So we need the files for the variant and the list of parts for it, the list of unique parts for it. So let's refresh our memory a little bit, because the list of parts was one of the artifacts from the assembly variant builder tool. So what we had was our variant builder, right? And it gives us this part tree at the end of it. And and at the end of all this, it also gives you a CSV file. And the CSV file contains the ref des, the manufacturer, and the manufacturer part number. And also this flag, but we might care about this, I'm not sure yet. But the main things we're interested in is these two things here. So we want a unique list from this. So if you've got the same resistor placed twice, right? Yeah, if you've got the same resistor placed twice, then you only assign it to one process. Yeah. Yes. Okay. So I suppose well, there's a couple of ways of doing this, really, isn't there? Because we could have this tool do this processing of unique parts, or we could have the other tool doing it. I think probably the other tool should do it because it's what needs that. Yeah, okay. So we've got to read in this CSV file, probably sort the list by manufacturer and part number, and then remove duplicates as we go along. What's the thing that needs to happen after this? Let's have a look at that. Oh, it's just mouse wheel. You guys can't see because my head's in the way. Hold on. Let's bring that over there. Now we can see. Alright. Yeah, so choose process for each part. Create a phase for each process. Assign a loadout to a phase. And most of these things are pretty trivial. It's just like, this is that, and this is that, and this is that, and it's done. And then assigning parts to loadouts. That's slightly trickier. Loadouts, and then yeah, okay. Yeah, so then only at this point where we've got choose placement ordering for each phase do we need the list of reference designators. That's what I was trying to work out, where we next needed them. Now, it's possible at any given time you might want to double click on a part in a user interface and have it give you a list of ref deses that are applicable for this phase of the process of the assembly. But you can do that, you can cross-reference it and look it up, regardless of whether you keep them to hand. Okay, fine, I think we're good. So, choose process for each part. So we've also got this somewhere up here, we've got this choose process. Let's deal with that. Alright, here we go then. What are we going to do? Let's create a new test. Yeah. So we could say that when you create a project to start with, it's got a list of processes in there straight away. Let's do that. Let's say when you create a job, you have processes, and it's a list, and it's, what is it? Is it an ordered list? Do we need to specify order here? Is it like pick a place and then manual, for instance? But let's just go PnP to start with, right? Done. So, obviously this is going to fail. There we go, look, it failed. Fantastic. So let's make it not fail. We can probably make it not fail by saying that a project has processes, which is going to be a vector of process. Now, should process be an enum? Or do we want to retain some flexibility in that a user can define their own processes? Oh, I don't know. Multi might have a go at me if I don't use an enum. we could limit the scope of our thing by using an enum. Let's use an enum to start with, and then go from there. I think we'll go with that. Let's go enum process PnP, and that's it. That's all we want. I think we need these, but I'm not entirely sure right now. And then what we're going to need is, when we create a default one, we default this to PnP. And then some way later in the future we can add to this list of processes. But this is enough for now. We just need one process that we can assign parts to. Yeah. Okay, let's see what happens if we run everything. Right. So yeah, I think it does need these. Okay. Oh yeah. I think this needs to be public. Right, but it failed. Why did it fail? Processes, PnP. How is it different? It's lowercase, but here it's uppercase. It's got this on it. So there's probably a way of like having the enums come out in a particular format when you serialize them and deserialize them. I mean, should it be PNP like this? No, because that's not rusty, is it? Let's add the rename all thing and see what happens. Yeah, it didn't do anything, so that wasn't the right way of fixing that. Oh. Rename all. I think we have to go just like this because I had serialize instead of deserialize. Yeah. Is it like this? Let's guess. No. Oh well. Serialize field. There's a. It'd be nice to find the rename all in the Surday. Trying to find it. Trying to find the arguments that you can have for the rename all thingamajigmy. Rename all. Oh, do we just go like. Wait. Do you just go like this? No. Oh, well, you need to specify both. Oh, I changed the wrong one. Hold on. Oh, dear. Why didn't you guys tell me? Okay. Right, now what happens? Okay, this is good. We're missing a comma now. Good. Alright, cool. We got there. Fine. Needs a comma. So that should be okay. And now, of course, this one, the other one is failing because it doesn't have the processes in it. I imagine. But let's find out. Yeah, there we go. Right, great. So we've got a process, and now we can assign things to it. Okay. So I guess we should do a commit at this point and say that we added a default process. Seems reasonable. And I think this should be like this really as well. I haven't got a test for this, but I think it should be. Because we're serializing and deserializing this, and I didn't update it because I'm a very naughty developer. Yeah. Unit assignments, yada yada yada, yada yada yada. Right. Use a default process for new projects. B&B process for new projects. I mean, we're in the business of creating pick-and-place machine software, so the default being P&P seems reasonable to me. Right, okay, so we've got a process. Let's go back to this again. So we're trying to choose a process for each part. But we don't have a list of parts yet, so we can't choose a process for it, so we need a list of parts. Let's get a list of parts from somewhere. So what we've said, how are we going to get the list of parts? What we've said that you've created a job project and you've got unit assignments, and the list of unit assignments contains the design and the variant. So therefore you can get a unique list of designs and their variants. And then once you've got a unique list of designs and variants, you can go and find the files for each of those, which contains the details for the placements for those variants. Okay. And then we can load them up and then filter the duplicate parts. We may want to retain some sort of like reference to where the parts came from, but I don't think we do yet, so let's not. Okay, so we have to look at our unit assignments in order to work out the design and the variant. Now let's go back to our variant builder. And this is what it spits out. And when we tell it to create this file, we specify like a name of this thing. Right? So let's just say that unless something tells us otherwise, the name of this file that we're going to look for is something like design A underscore variant underscore A dash placements dot CSV. Great. And we repeat that for each of the units in the list. Okay, so we're going to need a CSV file. Yeah. Okay, so here's a CSV file. So let's use that in our planner tests. Okay, so I'm just gonna schlep this in here for now. And then we're going to create a new test based on one of the other ones. And then we're going to have to fix some things, because this needs to be number 4, and this needs to be number 4. Yeah, there's some weirdness here, right? Because the tests are run in alphabetical order by cargo, right? But they can run concurrently at the same time. So then the locking method needs to know which one is supposed to be run first before the other, and it doesn't know anything about the name of the method because there's no reflection in Rust. You have to do it with like macros and all this kind of stuff, right? So maybe you could do some of this automatically, but we're not doing it yet. For instance, by defining our own sort of annotations and attributes and so on like that to do this bit and this bit magically. But we're not doing any of that, so we have to fiddle around with it. So this one is going to be sequence 3, and it needs to be sequence 3 here, and it's not assigned this to this. It's something like well, I mean, we said choose process for each part. I mean, what are we going to do here? Yeah, I suppose we can specify like an argument and say star, right? And then have like some wildcard little matchy thing, right, to assign parts to it. And then you could run the same command a whole bunch of times with different arguments to go through the entire list. And it seems reasonable as a first cut. choose process for parts. Yeah. So we're going to run it. It's going to use the same things. But it's not this. It's going to be choose. I'll deal with what we expect out of it in a moment. Choose process for part. And if we say part, because we want it to apply to multiple parts at the same time, and we're going to say process PnP, right? And if we say parts, and we just say star, and let's let's do regular expressions. Dot star. Sure. All of them. Why not? Right, so we've got our args, and then we need to print some stuff. To do, I don't know what we're going to print there yet. And we're going to need the list of parts and the process that they are assigned to. Now, do we have it one way around or the other way around? Because a part is made up of two things, which is the manufacturer's name and the manufacturer part number. Whereas a process is only made up of one thing, which is the process. So perhaps we go process to part instead of part to process when we've got this list. So I don't know, what do we have here? So it's process. Let's say process part assignments. Why not? And if we say that the PnP process has a list of parts, and that list of parts contains res murfer1 it's going to be an object. It's going to be manufacturer, but it's JSON, so it needs to be in quotes, and then it's going to have an MPN of res1, right? Yeah. And then it's not going to have a comma there because it's JSON, but it is going to have a comma there. We're going to do another one. Sure. And let's do, I don't know, conmer for 1, and it's going to be con connector. We're going to have connector. 2 resistors and a connector, sure. Why not? And they're all assigned to PnP. Right. So now we need a design variant with a given name and a list of parts, which was this stuff, right? So let's take that. And just schlep it in here for a moment. Oh, what's going on? Oh dear. And there's a better way of doing all this. Hold on. Let me fix this. Oh dear. Why is it doing that? Oh, we've got Music B. Music B stolen my Alt-J keyboard shortcut. That's a bit dumb. I suppose we're going to close it. I mean, Alt J is a bit generic, don't you think? Music B developers. What were they thinking? Oh god, don't do that. Oh, my doorbell's ringing. Hold on, back in a minute. Right. Sorry about that, everybody. That was pretty random. Right, yeah, so we're trying to go R hash and then a hash at the end, I think, and then that's supposed to do it. And then you can use quotes everywhere. No, not there. I've got this in the wrong place. It's supposed to be here, maybe? Oh, I need to look now. Where is it? Oh dear. Here's the example. You go in doc and you go whatever and you do this at the end of it. Yeah. What's wrong? Oops. R hash quotes. I don't know. String literal without suffix is invalid. Is it? Oh, there was an accidental extra hash in the wrong place. Fine. Okay then. Right. So we can define this a little bit clearer now. Let's deal with this stuff. Make a nice file that matches our expected input. Yeah. We said R1 and manufacture 1, manufacture 2, res 1, res 2, con manufacture 1. So these manufacture 1, res 1, manufacture 2. Yeah, that should be about right. Let's say design a variant a CSV content, right? Placements CSV content. Yeah. Okay, so we need to write that to a file, but we need a file name before we can write it to a file. For some reason I thought, yeah. Okay, there's something else I've just noticed about this this bit of code. It should be in the context now, this thing, because it's common amongst all of them now. So we're going to try and move that into this context thing. which is going to be something like this. And I think yeah, and I think we need the argument should probably also be path arg. Where's the name arg? Name job 1. This name job 1 argument is also duplicated between all of these things now. So let's move that to the context as well. Context dot name arg. Yeah. Whoops, a daisy. Context. And then we go name arg. And we're going to do the same for this bottom one down here, which is this one. And then down here, we've got our other one, which is that one, right? Everything's good. Test project path. And this then needs to be context dot yeah, and then we can delete this and then get it from the context again, and delete this and get it from the context again. Not VTX, context. Okay, fine. Everything's good, right? Everything's totally good. Right, so we've got our CSV thing. So now we need to create a file and with the appropriate name. So let's say I guess we need a let's just say placements. Oops, daisy. Path. But we need to put it in the right directory. So we have to get that directory from the context is tempder path to path buffer, right? And then on that placements path, we need to push some formatted name, which is going to be made up of the, well, I mean, we don't really need to format it, do we? Because we can just type it in. Sure. So we're going to go design a underscore variant a underscore placements dot CSV. And this needs to be mutable. Great. We don't need to add it as an argument because it should just work it out. But we do need to write this content to this file. Let's do that. Okay. Sure. What do we want to do? Let placements file is file new, and then some place. Oh no, create placements path, something like that. And then we go placements file. Can you go? Is there an API to let you write a string to a file in one go? Because I thought there was like a read from. Oh, what happened there? Read file. I mean, there's read file, so maybe there's write file as well. Where's this? Where's this live? Predicates. Read to end. Okay, let's just see if we can go. Oh, question mark. Right, I suppose. This. Well, it probably needs to be mutable. But then what's this? What does write take? Okay. This is a string. Does it need to be a string? I don't think it needs to be a string. Does it want a reference to this? What did it say it wanted? Write. That's bytes, isn't it? Yeah. Yeah. Sure. Now, when does it close this file? Like, when does it close it? Because the production code is obviously going to need to open it, so we can't hold on to the file handle, right? So if we flush it and flush. Takes a mutable reference to self. Let's try it like this. Maybe there's some more work we need to do, I don't know. Right, so we've got a CSV file containing some placements now, hopefully. I suppose we could schlep a breakpoint in here and then run all the tests until that point, right? But it failed. Oh, yes, it's because I'm a moron. No, I'm not. Everything's fine. Not sure why it got to there. Let's rerun it from here. But pressing debug. That's why. Okay, fine. So we should be able to look at this file now. Oh. Copy value. Duh. here we are. And we're gonna schlep this in here. We've got a CSV file. Yeah. And we got our project, and we've got a trace log. Okay, fine. Everything's good. Get rid of that. Fine. So obviously the test is going to fail because it doesn't know anything about the command that we've just built. But we've got a failing test now with at least some of the things that we need. So it failed because it doesn't know what this command is. So let's fix that. Let's fix that by adding a new command. Choose process for parts. Sure. Or should we, I mean, I typed that in, but are we assigning stuff? Assign process to parts. Yes, and I know we're storing it the other way around, but everything's fine. Assign process to parts or assign parts to process. Let's do it the other way around, and then it matches what we're actually storing. Then it might be a little bit easier to remember. Right, fine. So we want again the, no, do we? What do we want? We want the process. Yeah, process. Sure. I don't know. I don't know whether clap can give you a short list of the things if it's an enum. It might be able to, so I'm going to leave that blank right now. And we're going to say, it's an arg. You need to specify the long name, and that's all I know right now. So we've got a process, and now we need the. Well, we said star, didn't we, in our test? And I think that might be a problem. Let's go back to the test. So we said parts as star, but the problem is a part is made up of two things, isn't it? It's made up of a manufacturer and a part number. So do we want to specify two arguments, and we go manufacturer and it's a regular expression, and manufacturer part number and it's a regular expression? And if either one or the other is missing, then treat it as if it matches everything? Or do we always want to specify both, which is easier to do to start with? So let's do that. Let's say manufacturer and MPN, and you specify both. Yeah. Okay. So we're going to say, I don't know. Something like that. It's going to be manufacturer eventually I'll hit the keys in the right order and the word will be spelt correctly. And we're going to say regex pattern. I don't know. Should we just make it a string for now and just make it a string for now, and then we'll come back to that later. Because if we have a value parser and it's of a particular type and we expect a pattern, and if the pattern is malformed, then it'd be nice to do that. Maybe we can already do it. Can we go regex? Let's look for the Rust standard library API for pattern. Rust regex API. Where does it live? Crate. A crate. Is it not? I thought it was built into the standard library. Really? I mean, is it not? I suppose it's not. I mean, I kind of thought it was. I'm a little surprised right now. Rust regex pattern instead API. Does everybody use the regex thing? I mean, no. See, because look, it's only got this. Why does this exist? Okay. Let's just look in the standard library, because I'm pretty sure it's in there somewhere. Oh, it's called regex. Hold on. Okay, 281 million all-time things. Yeah, it's probably the right one to use. Sure, and we already have it as a transient dependency, look, so, you know, let's just go with that. Cargo. Regex. That one, yes. Don't know why there's a space there. Sure. Everything's fine. So, is there a... Is there like a... Yeah, pattern. Here we go. Pattern. Coaster pattern. Pattern. But, what? Generic mechanism for different pattern types when inserting through a string. Oh, interesting. I mean, interesting. Okay, fine. was wondering whether there was like some parse method on the pattern API which we could use. I mean, can you just go regex and then parse? Is there a from stir? There is. And there's a try from. Okay. We good. So we can try from stir for this thing. But let's use this here and see what happens. Sure. Seems reasonable. Okay, let's run it because I forgot where we got to. Clone is not satisfied. Well, process fine. Sure. Okay, we can define clone because the other things that we're doing here needed clone as well. So fine. Value parser exists for blah 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 process, but it's trainer. Okay, so yeah, that's fine. So how do we make this thing? How do we make this thing usable by clap? See, mixing bloody command line arguments and serialization, all this. I don't really want to be starting to add sort of the serialization and deserialization stuff. I'm sort of happy with being here because this is an internal data structure that we're trying to create, which is part of our project, right? But adding clap stuff here, no. Let's go process arg here like we did in one of the other ones, and let's make this an enum. And then we have to derive some sort of clap stuff from it. I don't remember how. Let's go to the clap docs. Rust clap derive enum. Come on, Google. Let's go. Clap value enum. Is it this? It probably is. But it's a year and 10 months out of date. Value enum. Yeah, here we go. Parse arguments into enums. Yes. When deriving a parser, a field whose type implements value in. But do you have to? Value enum? What's value enum? Is it supposed to be like this? Like this? We've got a derived clone, so we'll do that, sure. We get the same thing. But does that mean... Can we have an example of an enum? Here we go. Derive subcommand. Don't care about this. Here we go. We need this. Maybe. Let's take this away from here because I don't know. Is that right? That it was right. Okay, good. So we need to somehow magically go from this process arg to a process. I'm just going to create the new, very basic one of these things. Impl from process arg for process. Does it compile? Yes, this is good. And then we go match value BNP process arg BNP goes to process BNP. Sure. Right, great. We're getting there. And now we need to add this into here, and we need a block for it. Okay, fine. And then we need to do something. Great. So we can go let process we should be able to do that, which is a really weird line to write. Yeah. Maybe this should be called process arg. And it might be a little bit clearer. Sure. So, you know, we can use this in our project thing now, where we've got our list of assignments. So, I guess we need to load a CSV file now. Now, there is some overlap, is there not? So, in our variant builder, we create some CSV file using some placement records, and those are the same placement records that we need to read back in this bit of code. So we could potentially read them all here. So if we were to say yeah, let parts it's going to be a bit of a problem if Yeah, I can see how this can go very pear-shaped very quickly, but we're not going to deal with all of how it can fail just yet. What we're trying to build is the process part mapping, essentially, or the assignments. Firstly, we need a list of parts, and then we need a list of unique parts, and then we need to match the patterns against the parts, and then if they match, add them to the assignment, process assignment. So let's create something called all parts, and it's going to be a vector of part, and it's going to be empty, and it's going to be mutable. Fine. All right. And then if we say and we've got this. Well, we need a project first. We've got a load of project. Okay, so we've got a project. Fine. And then we need to iterate over the assignments used in the project. But really, we need a unique list of these first. Oh gosh. Okay, so let's not do that. So we need to get all of the things out of it. Iter probably, and then go perhaps. Is there a unique? Damn it. No. There probably is a thing to get all the unique ones. Unique things from a list. But, well, hold on. I mean, I guess we could fold it and create a new list, right? So I think we're supposed to create a vector of design variants. Oh dear. Which is probably going to be something like a vector of a tuple structure of design name and variant name, right? And you create a new one of them, and then you run a function which takes an accumulator and the item or something, and then you run some stuff on it, and then at the end of that you collect it. And then I suppose you could go if the accumulator contains. Oh, this accumulator needs to be mutable, I think. And I've probably got the syntax for this fold thing wrong as well. Let me look at how to do fold. Oh. What? Ah. Why is it showing me that? Fold. And then there's an iterate a macro. There's an implementation fold somewhere. There it is. But it doesn't give you any docs. It'd be nice if the documentation was a bit easy to find for this fold thing. Perhaps it's not like that. Perhaps it's like this. Yes. Okay, fine. But like, what is this? This is it's a unit assignment. Contains item dot design name dot clone and item dot design variant name dot clone, perhaps. If it contains that, then if it doesn't contain it, then accumulator dot push oh no, thing, whatever. If it doesn't already contain the thing, then push the thing. Something like that. With another bracket. And then why can't I push the thing to the accumulator? Value used after being moved. Contains... probably like that. Okay. So then we can go for design variant in unique design variants. Yeah. And then we can build the name of a file and load the file in. Placements. Well, we've got this. We've got this project file path, right? This project file path comes from ops.path. We might be able to use that. Okay, and then we should be able to go placements path dot push, and then we can use our format thingy. And we're going to say it's the name of the design, the name of the variant with placements.csv on the end, right? Yeah, why not? Now this is all a bit CSV at the moment, but there we are. This needs to be mutable. And we need two arguments here, which is going to be the... well, I suppose we can go design variant. I don't know whether this toString is going to print out the thing. We implemented display from the. Yeah, we did. Okay, we should be okay. Perhaps we don't even need to do this. I don't think we need to do this. Right. So we've got this placement path. And then we're going to do something with it. What are we going to do? We're going to try and read a CSV file from that. So we did these placement records, we did a CSV reader and all the rest of it. Who remembers how to do that? No. Okay, me neither. But fortunately we got some CSV loaders in a place we could find them easily. This is our part record, loadout item records, this is all fine. Substitution records, fine. Who remembers how to load CSVs? Oh, I'm looking in the wrong place. Yeah, you do this. Here we go. CSV reader new from path, placements path, and then you get a reader of type file, and then you can call deserialize on the reader to get the appropriate records from it. And the type of the record depends on how you assign it. Fine. So one of those, but not this one. Oh, look, we were so close. Look, placements path. Right. So now we've got a CSV reader, and then we can do this. Right? And then what we're trying to do is add the parts, this vector of all parts. And maybe we want a hash set here, and we can go try append or something, or try insert or something. I'm not sure about that yet, but we don't want this type of record. But we need to create a part and add it to the list. Now, I don't remember when we saved our CSV file what the mod was. That did the CSV saving. Let's see if we can find it. Write output CSV, look. And we basically got this record thing sort of stuck here at the moment because it was only used by this function. But we need to reuse this same thing now. So we probably need to move this somewhere. And we've got this loaders. Yeah, loaders. Yeah, sure, you know, I want to load these things. What am I doing? Placements. Do I create a loaders for placements and put this thing in here? Probably. Let's go. Look, and we've got EDA placements, and let's say pub mod placements. And there is a difference between the two. Okay. So let's take this, put it here, and call it placement record, and then derive deserialize as well. And then we want Pascal case in both cases now. Right, fine. Okay, now we can go back to where it was used and rename this to placement record. But we can't do that because it's not public, and now it is. So now we go back to it. Now we can import it. But the things inside it aren't public, so we have to add public on these as well. Everything's fine. There we go. Right, good. Right, fine. So now we can reuse that. And we'll probably extract some of this loading stuff into the placements loader file that we just created in a minute. Great. So we can say let part equals part, and then we can give it the things, which is going to be record dot manufacturer and record dot manufacturer part number, right? So we've got a part and we can add to a list of parts, but it might be added twice, more than once. So we can say if not all parts contains part, then add the part. Right. I know it's probably going to be hideously slow, and we should probably use hashes and all this kind of stuff, so the lookup is done in a more reasonable amount of time. But that's an optimization. Don't optimize too early, no. We're supposed to use reference there, I think. And I want to compile this fairly soon because there's lots of code. And then if we just say down here, perhaps another to do, and let's see if it compiles. No. Okay, there's no partial EQ on design name, so fine. We'll just add partial EQ onto this. And this, and also this for good measure. I don't think we need it on that last one, but oh yes, and we need to return the accumulator at the end of this fold thing. Yes. He doesn't know how to collect this. I don't think we need to collect here, because fold just returns the thing, doesn't it? Yes. So I suppose compiles. That's good. So what we can do just temporarily is completely ignore the fact that there are indeed patterns that we need to use, and we can just add them to the list and then come back and add another one into the test that shouldn't be in the process list. I don't know. But let's just do that for now. So we can say for part in all parts, and then go project dot something. I think it's what did we say it was? Was it part assignments or process assignments? Who remembers? Who remembers? Anybody? Anybody? I can't hear you. Yes, Darkman, cicadas. Can you hear them on the mic? That's interesting. They must be at a similar frequency to human voices then, because there's filters set up on the mic. Where do we get to? So we said process part assignments. Dot. Well, what is this? This is sort of like it's kind of a hash map, really, isn't it? But I don't know when Rust serializes a hash map, what it looks like when you try and serialize it, because the key is the process name and value is something you want to futz with. It's sort of like this, isn't it? Let's say let assignments is this. Sure. And therefore this project thing needs to have something else on it. Let's say it's a hash map of process and part. Yeah. So process needs to be able to have a hash on it. So let's find this process. This is going to need hash on it because you can't put it in a hash map unless... Is it a hash map? Yeah. Unless you can derive a hash from the thing. Fine. Okay, so we've got assignments. So we can go, and therefore, why doesn't it know what this is? Process is a process, which is the key for the thing. So at this point it should know what this is, but why doesn't it? I don't know. Yes, I know I can do push all here, but that's not the point for when you're doing regular expression matching later, is it? No. What happens if you do... Why do... Oh, now it's word stamp dot get. Where's get? Yeah, why isn't it like that? How am I using hash map wrong? You could dot entry. Okay. Really? But not entry. I don't want the entry. I don't care about that. No. That's wrong. It's not one thing to it, is it? It's a vector of parts. That's better. We can probably go .default on there, right. So then we get a mutable vector of parts, which is what we want. At least I think that's what we want. And then perhaps we just go project save at the end here. And then here we go to use buttons before adding parts. Only add parts not already in the list. And potentially you can use a hash set here as well, I think. And probably we should be using that hash set somewhere else as well. To deal with this in both of those two places. Let's just see what happens here. Well, yes. I don't think it knows how to serialize a hash map. Well, process needs EQ on it. And probably partial EQ as well. And that one, yeah, fine. So it doesn't know how to serialize a part. It doesn't know how to deserialize a part either. So let's add these to part. I'm going to do them on a separate line for now. Okay, this is good. Okay, we're getting there now. This is good. This is good. We're getting further than I thought we were going to get here. I guess we create a default empty hash map. Apparently we do. Yay. Right. Let's delete some. Variable does not need to be mutable. The thing, I suppose, is design variant. This is a design variant. Sure. And we don't use the manufacturer, and we don't use the partner. We'll leave those to do this because that's perfect. That's exactly what we want. That doesn't need to be mutable because we're not ever mutating it. Yes, we're good. That's perfect. There we go. Right, what happens if you run it? Oh, well, you know, some things fail. But whatever. Process part assignments. I wasn't really expecting that to be an object. Yeah, and I think we need to change our assign parts to processes thing. Yeah. Okay, that's fine. Let's fix that. We're assigning parts to one process at this point, so that's fine. Assign. Oops. Let's do that. Okay. Unrecognized subcommand. Assign part to process. Is that what we had? Assign parts, plural, to process, singular. Okay. Okay. This. I mean, we've got a to do. Yeah. No. That's right. We've got a. Let's comment that out for the moment, because I want to see what the job status content looks like. Look at this. We've got a list of stuff. Okay, so our expectation is slightly wrong due to the way that we are doing stuff. Let's have a look. So we said process to part assignments, and we said it's an array, but when Rust serializes, you get an object. So that's not the end of the world. Wasn't expecting that. But I guess it's okay. Okay. It's looking pretty good. So we're expecting one too many commas here. And look, we've assigned parts to processes. Yay. Okay. Amazing. Right. Well, but we've got lots of other things to fix up. This should be fairly trivial to fix these up. Let's do a little bit. I think I'm going to take a break from this in a bit. This has been quite a bit of a mission. So we want this, right? And this next one is going to have this kind of thing on it. So let's see what happens now. Oh, look, they're all good. No args is going to now need the extra thing on it. Assign parts to process. Fine. That's going to go in under here. And then we're going to need to fix the indentation for the other ones. Okay. But we're missing a couple. We're missing a test for this new thing. Right. We're missing a test. No. Right, so the thing that we want to test for is this argument, right? This one. I don't remember what the arguments are, so I'm just going to let it tell us what they are. I know we don't have design and variance and units, so we'll get rid of all those. And the thing that we're trying to run is this, so we want the help argument for it. And then in our bin we said this, so at least that bit should be right. But this name of the method needs to be fixed up. Parts to process. There we go. Right, and then we say go. Right, now it's going to tell us what clap normally prints out. So, again, this is one of these weird situations where you're sort of copying and pasting things because you're depending on the library, but you want to specify what the library should do when it does it. If you want to change this later. Yeah, we need all these things, and we'll review these after we paste them in here. Okay, so we want to specify process, and look, it does give us the list of possible values for this at the moment, which is good. And manufacturer and manufacturer part number. That actually seems right. Oh, the indentation. I was wondering what was going on there. There we go, that's better. Right, so everything works, we're done. No. If only it was that simple. We've got a big fat glaring to do here because we're not using these arguments yet. So I am going to take a break, and then I think I'll work on that and do a bit of refactoring and all that kind of stuff on this, and you guys can join me on the next stream. Yeah, so good progress today. So just remember, it's only software. How hard can it be? We'll find out on the next one. See you later.